Good morning. Now we will go for already we discussed the SOP, that is sum of product. Now we are going to solve the product of sum, that is product of sum POS form we need to say here. Generally what exactly the product of sum is nothing but the Boolean expression is purely in terms of a max term. That kind of expressions are called as a product of sum you need to say here. Generally the product of sum can be solved in two methods. One is a truth table method and another one is algebraic method. Out of this truth table and algebraic method, we will go for today only one, that is truth table method over here. Truth table method. So to apply the truth table method, you need to follow the two steps. The first one is prepare a table of input and output. Add one additional column of the sum term. Add one additional column for the sum term. Example: if x is equal to 1 and y is equal to 1, z is equal to 1, then that should be written as x, wherever 0 put as x, y is equal to 1, then y complement, z is equal to 1, z complement, as we did in the mean terms. So here there we supposed to use as a product, that is dot, but here we are using as a x plus. But if we convert this into SOP, we need to write down x complement, y complement, z complement. But now we are using as a POS, that should be x plus y plus z complement, like this. The same way here also written as x plus y complement plus z complement. Let us go with one example to understand the POS over here. So expressed in the POS form, the Boolean function is f of x comma y comma z, and the truth table for which it is given is x, y, z, f. So he has given the table over here. By taking this table only, we need to form the product of sum, that is max term. So he has given the table. So by taking this table only, we are using the. So what we need to do here? Just we need to add a column, add a new column containing the max term. So we are using as a max term over here. So same table has been placed over here. 4 zeros, so 2 zeros, so 2 ones, so 0 1 0 1 0 1 0 1, and here 1 0 1 0 1 0, like this. So when you go with these max terms, how to generate the max term? You should be clear with wherever the 0 you should use as only x. Wherever we have a 1, make it as a x complement, like this. Wherever the 0 we supposed to use as a x, and wherever we have a 1, we should be supposed to use as a complement. So we have a 0 0 0 x plus y plus z, and 0 0 1 x plus y plus z complement, and here is x plus 1 is y complement plus z, x plus y complement plus z complement, x complement plus y plus z, x complement plus y plus z complement, x complement plus y complement plus z, and x complement plus y complement plus z complement. This is the way of generating the equations over here. So out of these equations, we can conclude that the canonical form expression can be reduced into some canonical form equations over here. So wherever we have a zeros, that should be written over here. So we have a zeros is 1, 2, and as well as a 3. In mean term, we supposed to write only wherever we have a ones, that only we need to write down. But in max terms, wherever the zeros we have here, that should be only we have taken over here. So the equation should be generated as, so this one we should consider this one and as well as this one. So x plus y plus z complement, and x plus y complement plus z complement, and the last one is x complement to y complement, y and z complement. This is the whole equation what exactly we did in the product of sum using the truth table method, using the truth table method over here. And here, so you should be clear with these things over here, whether you need to use truth table or whether you need to use algebraic method. Which is the better one, you can go for that one. In examination, if they ask mention that using the truth table, you should go for only this one and don't go for algebraic methods over here. So now we will go for second method, the product of sum, algebraic method. So algebraic method, we have one equation called as x complement y plus y into z complement plus y. Convert this into the canonical POS form over here. Just apply the rules. Total 5 rules we have here in terms of algebraic method. First, we need to go for simplifying the given Boolean expressions using the Boolean algebra rules over here. So whatever he has given that we have written over here. So we have expanded this equation and we have generated the equation x complement y plus y complement z complement. This is the way exactly we can get over after when we perform the Boolean expressions over here. And next rule number 2 is saying that to convert into the POS form, that is product of sum form, apply the Boolean's rule over here. So by using the Boolean rule, we are going to produce the POS, that is product of sum form, using the above equation, that is x plus yz. That is, using this expression, we have converted the above equation, that is x complement y plus y into z complement equal to, well, reduced to POS form, that is product of sum. But don't get, that is, it is not a canonical product of sum form, but we need to convert canonical product of sum, but it is a POS form, that is product of sum form only. To convert the canonical product of sum, we need to do that now in sum of term are missing. It is nothing but in the obtained equation, place the place the variable where the variables are getting missed over here. In the above equations, x complement plus y, here is z is missing, and here is a xy is missing, here is a y missing, here is a x is missing over here. In that place, we need to place the value called as, that is missing variable add m missing value dot missing value. Example, if y is missing, then you should use as a y into y complement, as we did in the mean term called as y plus y complement. Like this, we need to add the term into the obtained equation, POS equation. So we are just take this equation here, and here is the equation x complement dot y. So z is missing, so z dot z complement. Here y is the only single term we have here. Here I am using as x complement, x into x complement plus y plus z into z complement. Here is a y is missing, I am adding as a y into y complement. Here is x is missing, x into x complement I am going to add over here. After adding the missing variables, then come to the rule number 4. Using the rule of using this rule, x plus yz equal to x plus y, x plus z. So we are going to reduce this equation into in this format, where exactly we got, that is 4, 5, 0, 4, 1. So these are the reduced equation. After reduced equation, this reduced, that is composed equation, should be added to the final equation. Here, don't get confusion that I am using as a plus b plus c plus d. What is a plus b such instance? I am using as a is equal to this equation, plus b is equal to this equation, c is equal to this equation, and d is equal to this equation. That entire equation should be written over here. That is converted into shorthand mean term, that is shorthand notation m0, m1, m2, m3, m4, m5, m6 and m7. Repeated terms should be removed over here. Then we get the shorthand value like this. After getting this one, remove all the repeated duplicate terms should be repeated. Finally we get the equation that is called canonical product of sum. Canonical product of sum form has been generated. So this is the whole procedure is for algebraic method. In examination, if is just given the expression, convert it into the canonical form, in the sense first you need to go for reduce that equation into the Boolean expressions and go for applying the Boolean rule. After converting it, you will get as a product of sum. So you should be clear with, if you want to convert the canonical POS form, first you need to get the POS. Directly directly you can't go from here to here. First you need to reduce this equation to POS form. After converting the POS form, then go for canonical converting form. What exactly, how to convert them POS to COS, that is POS na equations convert ಮಾಡಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, ಮಿಸ್ಸಿಂಗ್ ವೇರಿಯೇಬಲ್ಸ್ ಅಲ್ಲಿ ಏನು ಯಾವ ವೇರಿಯೇಬಲ್ಸ್ ಮಿಸ್ ಆಗಿದೆ ಅದನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಅದನ್ನ ಏನು ಮಾಡಬೇಕು, ಮಿಸ್ಸಿಂಗ್ ವೇರಿಯೇಬಲ್ ಪ್ಲಸ್ ಡಾಟ್ ಮಿಸ್ಸಿಂಗ್ ವೇರಿಯೇಬಲ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಮ್ಯಾಕ್ಸ್ ಟರ್ಮ್ ಇರೋದ್ರಿಂದ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, y into y ಕಾಂಪ್ಲಿಮೆಂಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಬಟ್ ಮೀನ್ ಟರ್ಮ್ ಇದ್ರೆ y plus y ಕಾಂಪ್ಲಿಮೆಂಟ್ ಅಂತ ಮಾಡ್ತಾ ಇದ್ವಿ. ಸೊ ಅದೇ ಈಕ್ವೇಷನ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಜಸ್ಟ್ ವಿ ಆರ್ ಆಡಿಂಗ್ ದ ಟರ್ಮ್ಸ್. ಹಿಯರ್ ಇಸ್ x ಕಾಂಪ್ಲಿಮೆಂಟ್ ಪ್ಲಸ್ y ಅಂತಿದೆ. ಸೊ z ಅಂತ ಮಿಸ್ ಆಗಿದೆ, ಸೊ z ಅಂತ ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಇಲ್ಲಿ y ಮಾತ್ರ ಒಂದು ವೇರಿಯೇಬಲ್ ಇದೆ, ಎರಡು ವೇರಿಯೇಬಲ್ ಮಿಸ್ ಆಗಿದೆ, ಸೊ ಎರಡು ವೇರಿಯೇಬಲ್ ಆಡ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಅದೇ ರೀತಿಯಲ್ಲಿ ಇಲ್ಲಿ ಕೂಡ y ಟರ್ಮ್ ಮಿಸ್ ಆಗಿದೆ, y into y ಕಾಂಪ್ಲಿಮೆಂಟ್. ಇಲ್ಲಿ y plus z ಕಾಂಪ್ಲಿಮೆಂಟ್, x ಕಾಂಪ್ಲಿಮೆಂಟ್ ಮಿಸ್ ಆಗಿದೆ, ಸೊ ಇಲ್ಲಿ ಆಡ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಸೊ ಅದೇ ರೀತಿಯಲ್ಲಿ ಇದೆ ಸೇಮ್ ಪ್ರೊಸೀಜರ್ ಇದೆ. ಸೊ ಜಸ್ಟ್ ಗೋ ಫಾರ್ until you will get as a canonical product of sum. ಸೊ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಸಮ್ ಮತ್ತೆ ಸಮ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಸಮ್ ಇವತ್ತೆಲ್ಲ ಹೇಳಿದ್ದೀನಿ. ಸೊ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದರೆ ಫಿಸಿಕಲ್ ಆಗಿ ಕಾಲೇಜ್ ಹತ್ರ ಬರ್ರಿ ನಾವು ಇರ್ತೀವಿ. ಸೊ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದರೆ ಡೀಟೇಲ್ ಆಗಿ ಕೇಳಿ ತಿಳ್ಕೊಂಡು ಹೋಗ್ರಿ. It is very difficult to understand these terms over here. Have reduced some maximum number of terms over here, but you don't get the panic over here. So be clear with these terms over here. Further in the classes, we will discuss this, how to convert this into the, how exactly what kind of problems we are going to face according to this product of sum over here. Okay. Now shorthand meter notation, that is in the previous we have generated the canonical equation form over here. So same thing has been considered over here. The same thing, that is f is equal to pi 01457 or f is equal to capital M 01457. Either you can write like this, either you can write like this. So be clear with this is a max term we are going to perform over here. Max term in the sense capital M it is. And here we are using as a pi. In mean term we supposed to use as like this and we supposed to use as small m. Clear? Let us go for this can be specified in the shorthand mean term max term as m0 dot m1 dot m4 dot m5 dot m7. Let us take one example. Convert the following function into the canonical POS form. F of x comma y comma z equal to pi m 0 comma 2 comma 4 comma 5. F of x comma y is equal to z. That is we need to convert this into like this. ಹೀಗಿದೆ ಈ ರೀತಿಯಲ್ಲ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ನಾವು. ಅರ್ಥ ಆಗ್ತದನಾ? ಇಲ್ಲಿ ಸಿಗ್ಮಾ ಇದೆ, ಸೊ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಆಸ್ ಎ ಪೈ ಇಂಟು ಸಿಗ್ಮಾ ಟು ಪೈ ನ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ಇದು ಮೇನ್ ಥಿಂಗ್ಸ್ ಓವರ್, ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಮೀನ್ ಟರ್ಮ್, ಇದು ಮ್ಯಾಕ್ಸ್ ಟರ್ಮ್. ಮೀನ್ ಟರ್ಮ್ ಇದು ಮ್ಯಾಕ್ಸ್ ಟರ್ಮ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವೀಗ. ಸೊ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಆಸ್ ದ ಗಿವನ್ ಈಸ್ 0, 2, 4, 5. ಸೊ ಸೇಮ್ ಈಕ್ವೇಷನ್ f of pi x, y, z 0, 2, 4, 5 m0, m2, m4, m5. m0, m2, m4, m5. So binary value for 0, 2, 4 is this is the binary value, and variable the 0 we have here. Place that variable as it is. If it is a 1, then make it as a complement over here. So here x plus y complement we are using 1. So 1, 0, 1. So x complement y complement, and finally we can able to write this equation as x plus this term x plus y complement plus z, x complement y plus z complement, and x complement y plus z complement. So add this entire the things into the to form a shorthand notations over here. This is all about your product of sum. In next class we will go with examples how to solve with these things, and we will go with the main question papers, and this carries a 5 marks questions over here. So be careful with preparations over here. Okay, next class you will see some of the examples how to solve the given boolean expression into either POS form, either sum of product or a product of sum, or either you need to convert the canonical form over here, either canonical SOP or canonical POS, and also shorthand mean term and shorthand max terms. So let us see in the next class. Thank you.